So let's get back to talking about how to implement breadth-first search in Spark. And as usual, there's more than one way to do it. I'm kind of describe the hard way of doing it just for educational purposes, but later in this course we'll come back and see how the GraphX library in Spark can actually make this a little bit easier. But for now, let's do it from first principles. So the first thing we need to do is transform all of this input data of our social graph of superheroes into the format that we need for our BFS algorithm. And if you remember right, every node in our algorithm had a count of distance from some other person we're interested in. It had a color indicating whether that node has been explored or not, or if it needs to be explored. And it also had a list of connections that we need to branch out from. So whenever we parse a line like this that indicates superhero ID 5983 is connected to these four other superheroes, we're going to transform that into a new data structure, kind of like this. So we're going to have sort of a tuple that includes tuples. It's okay to do that. Tuples can be nested and have more complex structure to them. So in this output tuple that we're going to put into our RDD for this data, the first entry in the list will be the superhero ID that we're talking about, followed by another tuple that indicates the connections to that superhero. Next entry will indicate the degrees of separation from the person we care about. And initially we're going to set that to 9999 just to represent infinity. Okay, really it should be infinity, but infinity isn't really a number, so we'll use 9999 as a proxy. And finally, the color of this node, which initially will be white, meaning that it is unexplored entirely. Okay, so that gives us to a data representation that's more aligned with the pretty pictures that we saw in the previous lecture. Here's the code that will do that. So we'll look at this in more depth shortly, but basically we'll split out all the different superhero IDs in each line of the input, extract the first one as the hero ID that we're dealing with, and then we will construct an array buffer. This is how we do that in Scala, and build up that list of connections to the superhero ID. So notice I'm using a variable here, a mutable object here, because I need to keep adding stuff to it and changing it as I go. We will set the color initially to white and the distance to infinity, 9999. Now, if this happens to be the character that we're starting from, say it is Spider-Man and I'm trying to measure degrees of separation from Spider-Man, then that's a special case. That's going to be gray, meaning that I want to explore that further, and my distance, the initial distance, will be 0 because Spider-Man is Spider-Man. And I will just convert that to the tuple that I want using the toArray object on my array buffer to actually convert that mutable array buffer to an immutable array. Okay, so that's what's going on here. Then I need to iteratively process the RDD just like we did in those slides before, where we go through one step at a time, branching out on all the gray nodes, coloring those nodes black, and then updating the distance on those gray nodes accordingly. So we just go through looking for gray nodes to expand. When we're done, we color that black, and we keep updating the distance as we expand our way out through the social graph. So the way we do this is by using a mapper and a reducer, a map function and a reduce function in Spark. So the mapper is responsible for creating new nodes for each connection of a given gray node. So as we go through the RDD of all of our nodes, when we find a gray node, we're going to bust that out into new nodes. So we're going to use flatmap to do that because we're going to end up with potentially more nodes than we started with, right? And at the same time, that mapper will make sure that we change the color from gray to black as we do that, and the original node we started with will be preserved and copied back into the results. The reducer is responsible for tying it all back together. So it will combine back together all the nodes for a given superhero ID, preserving as we go the shortest distance that it finds and the darkest color. And it also preserves the list of connections from the original node that we output from the mapping stage, so we don't lose any information. So that's all well and good, but how do we know when we're done? Any individual executor on our cluster might run across the character that we're looking for, so somehow it needs to signal to everybody else back to the driver script that we actually found the guy that we're after. So to do that, we're going to use something called an accumulator. And an accumulator is basically a shared object across the entire Spark cluster that maintains a count of something or some sort of a state. And it just allows all your executors to increment a shared variable across the whole cluster in a safe, thread-safe way. Okay, so syntactically, how does it work? You can set something up like this. We can set up a var hit counter, and we're going to say it's a long accumulator, meaning that it wraps a long integer value, and we can give it a name like hit counter or Bob or Fred, whatever you want. And what that will do is set up a shared accumulator value that every executor can increment it together at a safe rate with an initial value of 0 by default. So what we're going to do each iteration if we run across the character that we're trying to find, we'll increment that hit counter accumulator. So all the executors will say, okay, increment that value from 0 to something else if I run across this person. And then the driver script can check this accumulator value through each iteration and say, okay, well, if that hit counter accumulator is greater than 0, then I know I found the person. And in fact, that hit accumulator will actually contain the number of times that that superhero was encountered. It might be more than one. It might have been reached from several different directions potentially. So that's how we're going to message back to the driver script that we actually found the person we're after using an accumulator. Now the accumulator syntax actually changed in Spark 2.0. So if you're using an earlier version, the syntax is a little bit different. So keep that in mind. But we're going to do this the Spark 2.0 way. So with that, let's go off to the code and actually run it and get some reward for all this theory that we've been talking about and see it in action.